this is Mrs. Davidson again. I want to introduce you to our STEM lab. It's room 225 at Perry Middle School. A couple of things that are really important about the lab and why we even have it. Safety is absolutely critical in the STEM lab. In order to ensure the safety of all of our students, we have the Safe 6. And I want to review those for you so that you understand what is exactly expected when you are in the STEM lab. The first is that no equipment may be used unless I, Mrs. Davidson, am present. The second rule is that in order to operate any equipment, a partner must be present. So a second person must be present to ensure that you are safe, and if something should go wrong, there's someone to make sure that that problem can be communicated as quickly as possible. The third rule is that you must wear safety glasses at all times in the lab. Our fourth rule is that no loose clothing may be worn while you're using the equipment. So roll up those sleeves, tuck in the sweatshirt strings, and make sure that your hands are clear so that you can work with them on the equipment. The fifth rule is to turn off the machine when you are finished using it. And by that I mean it's important to make sure that the machine has come completely to a stop so that the blades that may be turning have stopped so that you ensure that the next person using it will be safe. And finally, when we're nearing the end of class, it is important to leave the areas clean. That means sweeping off all counters, sweeping up any sawdust on the floors, and resetting the room for the next class. Now it's time for us to drill the axle holes on our cars. And there's several things that we need to do. The first one is we need to select the right twist drill bit. And that is going to be 3/16. So we'll look for the 3/16 and pull that out. You want to be careful because they are a little bit sharp, so treat them gently. We're going to put that into the chuck and hand tighten it, and the chuck will automatically align the bit. But we just want to make sure, do an eyeball check like that. It's hand tightened. Now we're going to take the chuck key, it's spring loaded, and put the chuck key in and turn. You can see it's a bevel gear against a straight gear, and that's going to tighten down the chuck. We want that to happen because we do not want that drill bit getting caught in our wood, and we certainly don't want it going out and flying out on us. Kind of a note here, this is spring loaded, so our chuck key will never stay in the chuck. It'll automatically fall out. So that's a nice safety precaution. So I'm going to put that back here. Now notice I've got the backer board already on the plate of the drill press. The reason we use a backer board is to ensure that our exit hole on our car is nice and clean, so that reduces excess friction. I'm going to turn on the laser light, and locating the X, locate that X right down on the car. Now, in order for things not to fly away from us and get out of control, we're going to use a, here we go. We're going to clamp down our car. Before we even turn this on though, we're going to just run this down using the wheel and make sure that where we drill is exactly where we expect to. Now what's going to happen is I noticed that my table is way too low, so I'm going to have to loosen this, run it up, run my table up to the appropriate height. Let's tighten it up just a little bit and see if we've got the right. Go. We'll undo this. It'll be easier without that. Check to make sure our drill is going to go down. Looks like it'll go down in. We've got some more to go. Good. Okay, so now my table's at the right height. I'm going to turn that, lock it down. This is called a rack and pinion system. And we'll put our car back on. Notice that I've marked exactly where my holes are going to be. Those axles need to be between 5 and 8 millimeters from the bottom of the car. And I'm going to reclamp it. notice things have moved, so I'm going to realign it with my laser. X marks the spot. Make sure it's nice and tight. It's really important to have your car tight on this so that we get a nice clean hole when we go to drill. And let's just check it again and make sure. Oh, not quite right. So I'm going to back it up one more time. Make a tiny adjustment. Reclamp it nice and tight. Notice that I'm doing this without the drill press being on. We want to do that without anything moving so that we're very safe. All right, the last thing I want to do, now that I have things lined up, I've tested this to make sure that that drill bit's going to go right in the place that I said so that my wheels are, my axle's in the right place. I'm going to do a final check with my chuck key, and I'm going to go around all three. Make sure that that thing is tight. Here we go. Make sure it's back there. I don't need the laser light anymore, so I'm just going to go ahead and turn that off. I've checked it. I will now turn this on. And slowly, hand over hand, drill the hole in my car chassis. And you're going to feel a little change when the drill bit hits the backer board. There we go. And I'll slowly, I never want to let go of this. I just want to stay very slow. Nice exit holes. There we go. Turn it off. I waited until the bit, now I can see all the edges of the twist bit, and it stopped. Now I will unclamp it, drop it down, knock a little wood off, and you can see that my hole is exactly where I expected it. And on the other side, the exit hole is pretty good. Could have been a little better. We'll sand that. But that's going to be a really nice exit hole and axle hole with the least amount of friction that we can create at this point in building our car. Ready, you can see where I've got my design. Then I'm going to start some initial cuts on my car, and I've got that drawn out. Now I've got to get ready to use the bandsaw to start the shaping, the major shaping. And what I'm going to do is, the very first thing I will do on this is I want to make sure that my guard is about 1/4 inch above the wood, and it looks pretty good. I think I could loosen this a little bit, make it a little bit closer. Now by doing that, a couple things happen. The first is that it's safer for me because it's harder to get my fingers in there where I could get cut. The second thing is, when you have the guard lower, closer to the wood, you're going to get a lot more control over the blade so that you can do a better job with cutting. I also want to show you one thing. Now this isn't a very sharp curve, but I'm going to show you how to do a relief cut that might make it easier as you do some more dramatic cuts on the car. So the first thing I'm going to do is I'm going to mark where the relief cut should be, and I'll take it maybe right here, just a little cut right in there, and that'll make it easier for me to turn the blade and follow my line. So the very first thing I'll do, I do want to thank my partner for being here, who's actually behind the camera. So we've got someone here for safety, and that's always important. So I'm going to line it up, and I'm going to line up my cut mark really with the blade and pull it back. Now one thing I notice is that my hands are pretty close and they're inside the area, the circle of safety. So I'm going to go ahead and take a push stick. This is the push stick that we use. And I'll use the push stick to guide the car through. So my right hand is well away from the blade and my left hand is using the push stick. Push sticks don't bleed, so that's why we use push sticks. So I'm going to turn this on. I'm going to line it up gently, holding the runs a lot longer until it stops. So you need to be careful, make sure the blades have stopped. You can see the teeth. But I want you to see this little cut that I've made. That relief cut's going to allow me to make a nice, smooth cut my next cut. So now this time, I'm going to go around this way. My fingers will stay outside of that circle, and we should be pretty safe. So let's see how that goes. So this time I had some scrap metal, or some scrap wood, not metal, my goodness. So I waited for the bandsaw to stop. I can see the teeth. Now I can move the scrap wood. And I want to show you, I stayed outside of the line. The reason for doing that is you can always take more away, but you can't put more wood back on. So we can go now and use the oscillating spindle sander and sand this edge. Before we do that, I want to go ahead and finish this. I'm going to put another relief cut in there just to make it easier on the bandsaw. So we'll put another relief cut right in there, and we'll do the same thing again. All right, so we have cut out our car on the bandsaw, and now it's time to get some better curved edges because we want things very, very smooth so that our car just goes right through the wind and it can be as fast as possible. So the piece of equipment we're going to be using is the oscillating spindle sander. The reason it's called oscillating is because not only does it go around, but it goes up and down. So you can see that I went right along that line that was drawn here, and it's a nice smooth finish. Now I didn't finish this, and you'll see there's a little bump. So I'm going to want to clean that up and make sure that's nice and smooth so that my car is as aerodynamic as possible. Now you'll notice we've created quite a bit of sand and dust here. Typically our vacuums would be on so that we wouldn't see that. But when you're done using the sander, set your car aside, and we're simply going to brush off the dust, clean up our area because that's one of our rules, so that the next person can come in and have a clean work surface. All right, well that about does it for our safety training in the STEM lab at Perry Middle School. Just want to review our 6 rules again. First one is Mrs. Davidson needs to be in the STEM lab as long as any equipment is being used. The second is that you need to wear safety goggles. Third is no loose clothing, work with a partner, and always clean up. We went through 3 different pieces of equipment. We started with the drill press. Secondly, we went to the bandsaw, and we finished with the oscillating spindle sander. Now you're well on your way to finishing your dragster car or whatever project you are happen to be doing in the STEM lab. By the way, be sure to subscribe to us right down there. Take it easy.